Okay. Now we know that total energy of the system, that is kinetic energy plus potential energy, is equal to total energy of the system. Okay. The kinetic energy means half of mv square, and potential energy you can have function of x and t, both x and t is the total energy of the system. Right? E. Now this mv you can do half. You can do it by m. You can do this trick. We have xt is equals to e. So this becomes p. So is half. So it's p square by 2m plus v of xt is equals to e. Right? So your total energy is kinetic energy plus potential energy. So we writing this, we will be needing this. So E equals to p square by 2m plus v of x and t. And this potential energy is function of both x and t. For the time being, we are considering both the potential energy itself is a function of x and t.
Excuse me,
So
sir.
suppose we consider a system electron in a hydrogen problem.
Sir, your video is lagging.
The video is lagging, sir.
It is lagging.
Yes, sir.
And now the board is not clear.
Board is not clear. Hello? Now it's clear? Now the video is correct? Clear?
No, sir.
No, sir.
What?
So can you explain again, sir?
What?
Sir, your video is also lagging. It got freeze in between.
Yeah, that's the internet connection. I cannot do much about it. But can you see the board clearly?
No, sir.
No, sir.
No, sir.
The board clearly?
Not even a single word, sir.
We can't read out single word.
Quality.
भाई कोई नोट्स भेज देना यार इसके प्लीज.
Is it okay now? Hello? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So what I'm saying that yes. So this is wave vector psi equals to a to the power I kx minus omega t. It's the characteristic solution of the wave equation.
We cannot.
What? And then k is the wave vector and omega is the angular velocity. Okay. So here k kinetic energy plus potential energy. This video is also recording, so I'll upload the record. I'll also upload the derivation, so you can have a look at it. Okay. So start to follow as much you can. The thing is that so this is kinetic energy plus potential energy is equal to total energy, and then you have half mv square is equal to, so kinetic energy is half mv square plus potential energy, which is a function of both x and t, and half mv square means p square by 2m. So your total energy is kinetic energy plus potential energy. So E is equal to p square by 2m plus vxt, where p is the momentum of the system. Okay, p is the momentum of the system. Okay, and m is the mass and v is the external potential. So this equation is going to use it. That's what I'm saying. So now we know that from de Broglie's wavelength, from de Broglie's theorem, we know that P is h by lambda, where P is the momentum, h is the Planck constant, and lambda is the wavelength of the characteristic wave of the data wave, right? So now what you can do you can do it like this, h by 2 pi into 2 pi by lambda. If you do that, this is become h cut, and this 2 pi by lambda is k. Okay? K equals to 2 pi by lambda. We know that k equals to 2 pi by lambda. Y vector is equals to 2 pi by lambda, and lambda is our length. So that means the p becomes, so that means your k, becomes p by h cut. Okay? So your k equals to p by h cut. Okay. Now we know that from foundation of quantum mechanics, E is equal to h nu. From Planck's backward radiation, and also from Planck's backward radiation, and also from Einstein photoelectric equation, you already know that this E is equal to h nu. A is equal to h nu, where nu is the frequency, A is the Planck constant. Now again, it's the same thing. H by 2 pi into 2 pi by nu. This is h cut. Okay, it is defined as h cut, and then a 2 pi by nu is omega. So E is equal to h cut omega. So omega is equal to h cut by E. Okay. No, omega is equal to E by h cut. Sorry. Okay, omega to E by h cut. So omega equals to E by h cut. So you put this here. So if you put these values, this k and this omega here, so what it remains is, so your psi, which is function of x and t, is equals to a e to the power I. K means p by h cut, x minus p by h cut t. That is equals to a e to the power I by h cut px minus p t. Okay? So h cut will be taken outside the bracket, so minus I by h cut, so not minus, p by h cut. So this I by h cut, px minus et. This is a psi xt. Okay? Now differentiate this equation with respect to x. So del psi xt, del psi, del x. Okay? So this is how you differentiate, suppose the power mx minus alpha. Okay? So if you do that, then you treat this as a constant. So it is basically a to the power mx, m to the power mx minus alpha. Right? So similarly here, so if you differentiate this is a constant, and then you have to the power I h cut px minus et, you're doing partial differentiations. So you're doing second order derivation, partial differentiation you're doing. It's a partial differentiation you're doing. So you have to differentiate only x, and you treat t as a constant. Okay? If you're doing it, then a, then this t I by h cut will come down. So this we have I p by h cut. So you can write it like this: I p by h cut. Then again you have a to the power I h cut px minus et. Okay, so differentiating this term only. Now do a second order derivation, differentiation. Okay. Yeah. Right. So what will happen? So this again will come out. So I square. So what will have if you do a second order derivative? So I square into I square. So I square p square by h cut square. Again a e to the power minus I by h cut px minus et. Okay. Okay, so this is this. Right. Now if you concentrate, this one is nothing but your function. This is nothing but this. Right? So okay, this is our initial. So we have to resolve this equation. Okay, so this is nothing but time. This is nothing but time. Okay, so what it comes out here, del square psi xt second order derivation is equals to I square is what? I square is -1. Right? So I square is -1. I is complex number -1. So I square is 1 -1. So it becomes minus p square by h cut square psi of xt. Okay? Because this is nothing but this. This is nothing but this. Okay, so it becomes this. So from here, we found out what is p. So your p square. So your p square is equals to minus h cut square del square xt by psi of xt. Okay. Okay. So p square by 2m is equals to minus h square by 2m okay, so p square by 2m is equals to minus h square by 2m del square psi xt, second order derivative this one. Okay. P square, there's a mistake here. So this is square. So your p square is equals to minus h square square then x square by x square and divided by psi of x. Okay. Now we divide this term by 2m. Divide by 2m. So p square by 2m is equal to minus h square by 2m. L square x is xt. Then x square by psi xt. So this is your p square by 2m. Remember this p square by 2m. So we have to preserve this equation somewhere because we are going to use that. So p square by 2m is equals to minus h square by 2m L square psi xt by x square by psi of xt. Okay. Now derive this equation in respect to time. Can anyone derive this equation in respect to time? Tell me. Del psi xt by del t. Can anyone perform this? So x psi xt is equal to a to the power I by h cut as bracket px minus et. Differentiate this wave function with respect to time. Anyone? I'm just simply asking to do a partial differentiation of this function. Psi, which is a function of the particle, x function of x and t equals to a to the power I slash t, I h cut, first bracket ex minus et.
Minus IE
Minus IE
by H cut.
by h cut. Correct? Right?
Yes, sir.
Okay. This is nothing but the wave function itself. So this is psi of xt. Correct? I'm correct, right? Okay? Okay. So E, so tell me what is E now? E equals to then your E equals to minus h cut by I del psi del t divided by psi xt. Right? And we are letting E from here. It goes up, it goes down. So minus h cut by I del psi del t divided by psi xt. Okay, now I equals to over minus I, minus 1. So I squared is equals to minus 1. Right? So if you replace this minus 1 by I squared, then I gets cancelled, then you have E equals to I h cut del psi del x del t divided by psi of xt. Correct? Okay? Any doubts? Okay, so we got p square by 2m, we got E. Now we know that, E equals to p square by 2m plus v of x and t, function of x and t. So p square by 2m, so E means this one. So I h cut, so I can also write this way. It's equals to E. Okay. So now p square by 2m means minus h cut square by 2m xt x square divided by psi of xt is equals to plus v of xt is equals to E, and E equals to nothing but this. So E equals to, this is equals to I h cut del psi by del t divided by psi of xt. Right? So you multiply both the sides psi xt. So it becomes minus h square by 2m del square psi xt x square plus v of xt psi of xt is equals to I h cut del psi del t. Okay? This is called time dependent solitary equation. Okay? This is actually what is called time dependent solving the equation. Okay, so this is my time dependence on the equation. Minus h square by tm del x square del x del x square equals to v of external psi xt, which is equals to I h square del psi del t. So this is my time dependence on the equation, and from the time dependence on the equation, we are going to derive time independence on the equation. So now, let's write down the time dependence on the equation here. So minus h square by 2m. What you can do, you can also take the psi x xt out. So you can have this kind of function. Psi of xt is equal to e of xt. Oh, sorry. Is equals to, is equals to IH cut del psi xt of del t. Okay. So this you can also write. This is called Hamiltonian of the system. Okay. We'll come to it. So this is the solid equation. Now what you do? We want to make it time dependent and time independent part separately. Okay. So now what you do? This is my time dependent solid equation. So this del psi like this way, psi xt. So so minus h square by 2m del square psi xt by del x square plus v external xt psi of xt is equal to this. Okay. So here we assume one thing, that your v potential vxt is only a function of x, not in time. Okay, so your potential doesn't change with time. And if you do that, then your vxt becomes v of x. Okay, so now also we use the concept of separation of variables. That means we say that the function x and function t, they don't depend on each other, and you can have a separation of variable. So psi xt, I'm writing it that this is capital psi, small psi x, t of t. Okay? So the total wave function psi, this is actually capital psi, is small psi, which is a function of t only, and then you have another product of another function t, which is a function of small t, which is a function of time. Okay? This is called separation of variable. So if you do that, now put this here. So this equation becomes minus h square by 2m, and this is a constant with respect to when you differentiate the position x. So nothing going to change. It will remain same, and you have now del square psi by del x square. So now you have only one variation, that is the variation is position, not time. Plus, then plus we have, so plus we have v of xt, then we have psi of x, t of t, then you have I h cut. So I h cut del psi x del t. So this is also a separation of variable. So psi x comes out here, and you have what remains is you have to differentiate the capital T with respect to small t. Right. So I am just saying that this function x of t is a product of two functions, and then the product of two functions I am imposing here. Okay. So product of two functions I am just imposing here, and then that's it. Now I divide both the parts by psi x, and so I am going to divide this by this, both the parts with this quantity. If I do so, then you see this tt will get cancelled. So what we will have is the following. So Yeah, so this is what it is. Or maybe I can go to the next slide. This is going to be, what you can see here. Yes, this is going to be, then you're dividing it by, okay, let's do it here. Yeah, you're dividing by the product of it. So it becomes minus h squared by 2m, del squared psi by del x squared. No, I have to do it below it. I'm supposed to do that. Okay, so if you divide by both of them, then it becomes minus h squared by 2m, then del square psi x by the x squared divided by psi of x plus d of x. D of x is equals to I cut cut 1 by t del t by del t. Okay. So now if you close, if you can see this equation, in the left hand side, this equation as a derivative depends only on the x, and right and this side of the equation only depends on the time. So these two sides has to be equal to a third one, and that's why they are equal. Dimension is matching, but suppose your x is equal to y, it can also imply that x is equal to m and your y equals to m. That's why x equals to y. So if you say that, then this separately this has to be equal to something else. The something else is nothing but energy, E. So both of these two are independently equal to energy. Okay? These both are independently equal to energy. So you have two set of equations now. One set of equation is, it tells you that I h cut by t del, which is a function of t. So I h cut t, which is a function of t, del t by del t. Now we have separation of variables. Here you have only t, you have only x. So don't need to write the partial differences again. You can simply put the simple differentiation. So I h cut by t dt, which is a function of t by dt, is equals to E. This is one equation. Okay? Right, this is one equation. So the solution of this equation, how are we going to do it? So that means dt by t. So dt by t, okay, dt by t is equals to E h cut by I dt. Okay? Okay. Just putting t here, down here. So no, both will be here. So yeah, E by, so it will be I h cut. E by I h cut. Yes, E by I h cut. Okay, so this goes down and this goes here. Sorry, integration. So now in the I h cuts, you multiply by I. So this is I, this is I square becomes 1, so you get minus I by h cut. Okay, minus I by h cut. Now we're talking integration. Okay, now if you integrate over the states, over the time period, then what are you going to get? If you do this integration, then this will become this will become, so your t, okay, if you do the integration, then guess this. If you do the integration, then you see this will become, so your t is equals to, this is log 1 by t integration, right? So it becomes constant e to the power minus I e t by h cup. So this is solution of the time part. Okay? The solution of the time part. So what remains is this special part, which is minus h square by 2n plus, del x square by del x square plus v of x psi of x is equals to e of psi of x. Okay? This is called time. This is called time independent Schrodinger equation. Okay? This is called time independent Schrodinger equation. This is time dependent Schrodinger equation. This is time dependent Schrodinger equation. This is time independent Schrodinger equation. Okay? So to get to, so you have to solve this wave equation. You have to solve the boundary condition to get this psi. It can also be written as minus h square by 2m del square del x square plus b of x psi of x is equals to e psi. This is called the Hamiltonian of the system, the operator Hamiltonian of the system, the operator psi of x give you e psi of x. So you operate the Hamiltonian on a wave function, you get that total energy which is discretized. Okay? So you solve this, so you have to guess wave function psi and you have to apply boundary condition to solve this time independent Schrodinger equation, and finally you will get psi of x. So when you get psi of x, so when you get psi of x, the total wave function xt is equals to a constant psi x then e to the power minus I e t by h. This is the solution of the total wave equation. Total wave function having both space x and t part. X here, I mean x, we are considering only one dimensional. That's why it's x. So you have 1D Schrodinger wave equation. So that is a psi x e to the power I e t by h cut. Right? And that is how you solve. Now this Schrodinger equation you can use a boundary condition, and then you can use different. How to solve this time dependence on the equation? That is the question. Now it depends on the problem. How are you going to see the problem? How are you going to attack the problem? And then from using the problem you can solve the psi and the probability density and all these things. So I'm giving a kind of assignment to you because I don't think I cannot drive it. So let's focus on the time independent Schrodinger equation, and everything else I'm going to erase. So if you consider only the time independent Schrodinger equation, that is minus h square by 2m del square psi x square plus b of x psi of x is equals to e psi of x. If you consider this, now consider a situation of an infinite potential. Like consider a situation that is model situation, that this is a potential Vx, which is equal to 0 between 0 to say A or 0 to L. This is the length of the potential well, and here it is infinity. Right. So your V equals to 0 when x is between 0 to L and infinity elsewhere. Infinity x elsewhere. Okay? And is infinity. When x greater than infinity elsewhere. Between this it is 0. So if you do that, then your potential Vx term will be 0. This Vx is 0. So what remains is minus h squared by 2m del square psi by del x square is equals to E psi. This is only what remains. Okay, this is only what remains. So here, what it remains, so you can write this equation as del square psi by del x square plus 2me by h square psi of x is equals to 0. Okay? Or more precisely, you can write that x square x by kx square is plus k square psi of x is equals to 0. So this is where k square is equal to this term. Okay. So this is a wave equation, and the solution, the possible solution of this is the following. So it can have the solution of this, I know you are aware of that. The solution of x can be a constant, and then it can have a cos x, it can have sin x, or in general it can have e to the power I plus minus kx. This can be the solution of this particular problem. Okay. So this is our function. Now, what we do, what I'm giving you as to exercise it, otherwise you can do it and upload. So what we want to exercise it. So now, this is your wave function now. This is a very simple wave function now. So we have to solve this equation. So everything boils down only to this equation, solving only this equation, using boundary condition. The boundary condition is that psi x is equal to 0 here, psi l also 0 here, and it is infinite otherwise. So we have to make the boundary condition that the wave function has to be 0 here, has to be 0 here. Okay? So now, this is the del square psi by del x square plus k square is equals to 0. And you can construct a solution. Solution of this can be psi x, which is a cos x plus b sin x. Okay? This can be a solution. I mean sin kx. Kx sin kx. So this can be a solution of this particular system. Okay. Okay, or sorry, you can write this again sin x plus a sin kx plus b cos kx. Okay. Now we have to use periodic boundary condition to solve this. What is the periodic boundary condition? Psi 0 has to be 0. Right? Now if you put x is equal to 0 here, then sin 0 0, cos 0 1. Right? That means this b has to be 0. Right? So if you put x is equal to 0 here, then x is equal to 0 means this term is 0. X is equal to 0 is fine, but here if you put X is equal to 1, 0 here, cos 0, 1. So that means if this has to be 0, then this B has to be 0. So this condition gives you that B equals to 0. Now what remains is that sin x is equal to A sin kx. That is what remains. What is the second boundary condition? X equals to L is also 0. That means, which implies that A sin KL is equals to 0. Okay? Okay? Okay, now A not equal to 0. If A equals to 0, B equals to 0, then this wave function doesn't have any meaning. Right? When B equals to 0, A is also equals to 0, then there is no wave function. Right? So A not equal to 0. That means sin KL equals to 0. Right? Which implies that KL has to be n pi. You know from trigonometry, if sin x is equal to 0, that is has to be integer multiple of pi. So KL is equal to n pi, which gives you that this is basically KL is equal to n pi. Okay? Okay. Now your E is equal to P square by 2m. Okay? So now you got K is equal to n pi. Now your E is equals to P square by 2m. P equals to your P equals to okay. Your P equals to K h cut. So K square h square by 2m. Now here K equals to n pi by L. So your E equals to K square h square by 2m. So E equals to n square pi square. So your N equals to n square pi square h cut square by 2ml. Okay? Here n is integer. It's 1, 2, 3. So you can understand this E can only have quantized, only can have discrete energy levels, and that is energy is quantized. So by solving the Schrödinger equation, you can arrive at a point that E is quantized. E is equal to n square pi square h square by 2. So I think you already know. Now if you calculate the energy, if you got energy here, this is here E is equal to 1, and this is equal to n is equal to 2. This will be n is equal to 3. So the gap is not equal. The gaps will be separating. This has to be n square. E is proportional to n square. Okay, and that's how the energy is discretized. Okay. Now, how to find out the solution now? How to find out the solution then? So your solution x is now what? A sin kx, right? So sin kx means k is n pi by L. Okay, this is your solution. Now, how to find out A? You can do it by yourself. It's an exercise you can take. That this psi is the wave function of the Schrödinger equation. When you are solving for a particle in a box, when free particle, your potential is 0. You have considered. Here, the particle has to be in the box, right? The particle has to be in the box. That means if you do integrate psi star psi, you the total integration psi star psi dx, it has to be 1. Okay? That means if you integrate here, psi is no immediately here, so that means psi squared dx. So if you integrate it, if you square it and integrate it, it has to be 1. And from that, you can find out what is A. Okay, that can be figured out. What is A? So if you do that, it turns out that where A will be 2IL to the power half. Okay, so your totals, then your total equation is now, so your wave function psi x is equals to 2 by L to the power half sine n pi x by L. L is the length, and your energy is equals to n square pi square h cut square by 2m L square. Or should be L square there, sorry. Yeah, so this is the energy. So this is the constant. This term is constant. So you have n square into this. So your energy is discretized and you have a wave function like this, right? Okay? So I already told you about the energy. So energy, this is n is equal to 1. This should be n is equal to 2. And this should be n is equal to 3. But this is, if this is 1, this should be 4, this should be 9. This is 9 times n1. So it should be, the gap should be increasing. Okay. Now also you can do you can plot the wave function. This should be for n is equal to 1. This should be for n is equal to 2. And let us remove this. This should be for n is equal to 3. Okay, this should be the wave function. So we are plotting f of psi of x. So if you also can plot p of x, the probability distribution, then it will look like this is for n is equal to 1 and this is for n is equal to 2. Okay? So for n is equal to 1, finding the particle, the most probable probability is that at the center of the box. That is the most probable position that you can find a particle according to the probability distribution. Probability is of psi star psi. And when for n is equal to 2, the probability is maximum of finding the particle at position x is equal to half, 1/4. And at the middle is 0. Okay? That is basically the probability of finding a particle in the box. So that is a very interesting part of the quantum mechanics. Okay? I hope the marks too long. So I hope you have understood this. So this is how the quantum mechanics works. Okay? So this is the part. So interesting thing that for n is equal to 1, for integer 1, you have the finding the particle at the center is maximum, but for n is equal to 2, it is minimum. It is 0. You can't find the particle. math says that finding the particle in n is equal to 2 states is at the center of the length is 0. But for n is equal to 1, the ground state n is equal to 1, it is most probable to find in the x is equal to half h. So this is how the whole quantum mechanics works. So I'll upload the question paper. I'll upload this lecture notes. And if you have any questions, please feel free to ask me. Okay, so let's do the roll call. So 66 people are present today. Thank you, sir. So you have any questions? I will edit the video and I'll upload in the GRC so you can go to the derivations one again. Somebody asked yesterday that for a derivation, that's why I do it. So next day we'll do half the class quantum electrodynamics, very basic level, and half the class X-ray. And my portion will be over. That is Monday. So Saturday you have exam. Monday I'll take the class. Then the next 2 class will be taken care of by Alicia madam for the AI part. Okay, so shoot me an email if you have any questions. Let me take that as your batch A or B. Your batch A. Roll number 1.
Present, sir.
Roll number 2.
Present, sir.